All right, algebraic reasoning review, chapter 1.3 to 1.1 to 1.3, or 1.5 actually. For the following situations, determine what type of equation best fits the data. Then use the average differential ratio to write a rule to model the data. All right? You are measuring the amount of radiation a substance lets off every hour. The table is your record of data. Build an appropriate model, then estimate the level of radiation after 15 hours. Okay, so this is either linear or exponential. So you'll notice, I'm just going to give this a quick cursory. You notice how 15 minus 14, so it doesn't quite go down 1,000, so we'll say that's down 700. And we'll get a better number in a minute. This one goes down by about 3,000, because 4 to 1 is 3,000. This one goes down about, again, this is 3,500. And this one goes down 2,400. So these are very different. All right, so let's try this again. All right, this is probably exponential. So 14,310 divided by 1,500, 15,000. That is 0.954 on the money. Okay, 11,448 divided by 14,310. You get 0.8. Okay, really close to 0.95. 8014 divided by 11,448. You get 0.7000000. And then last but not least, 6411 divided by 8014. You get 0.7999999, which is essentially 0.8. Okay, so I'm going to erase this third decimal point, but I'm going to leave that 0.95 there, because it's not rounding up to 1. Let me type that in again, make sure that's correct. 14310 divided by 15,000. Yep, that's correct. Okay. So, this is exponential, because you notice how close all of these are. Alright, all of these are really close to each other. So, we need to find an average ratio. So, 0.95 plus 0.8 plus 0.7 plus 0.8. And there's 4 of them, so we'll divide it by 4. So 0.95 plus 0.8 plus 0.7 plus 0.8 equals 3.25 divided by 4. Yes, it is 5 divided by 4 is 0.8125, which you'll just round to 0.8. Okay, so y, this is exponential, so it's y equals a beta to the x. So y equals your starting point of 15,000 millirads. And your B value, your average ratio, is 0.8. Alright, the last bit says, estimate the level of radiation after 15 hours. Well, 15 hours is a measurement of time, so we're going to plug it in for x. Y equals 15000 times 0.8 to the power of 15. And I have no idea what this number is going to look like. 15000 times 0.8 to the 15th. Oh, that's not as low as I thought it would be. So y equals 527.8 millirads. And that would be your answer. Get rid of the box. Alright. Alright, I'm going to pause and move to the next one. Alright, you decided to walk away from your house and record the distance in feet from the house every 5 seconds. Below is a record of data you collected. Write an equation to model the data and calculate about how far you'd be after 5 minutes. Well, I'm just going to start by dividing real quick. I'm not sure what I just did. So 24.3 divided by 12.5 is, oh, come on, 1.94. 37.4 divided by 24.3 is 1.5. 50.5 divided by 37.4 is 1.35. And you notice these are getting pretty far off from each other pretty quick. So I'm just going to stop right there and try something else. Let's try adding and subtracting. So 24.3 minus 12.5 is 11.8. 37.4 minus 24.3 is 13.1. 50.5 minus 37.4 is also 13.1. And then 62.5 minus 50.5 is 12. Alright, so these are all really close. Alright, yeah, you got two 13s. This gap right here is probably a little big, but the fact that this is the high end and this is the low end, and a 12 is in between them, that's not bad. Alright, so let's add them up. 11.8 plus 13.1 plus 13.1 plus 12 divided by was 1, 2, 3, 4 of them. So 11.8 plus 13.1 plus 13.1 plus 12, enter, is 50 divided by 4. Well, that should be 12 and a half. Make sure. Yep, 12 and a half. So we have that. We don't have the starting point in this case. Alright, so you notice how these are going up by 5s, right? They're going up by 5s. Well, if I go down by a 5, I can go down by that step to 0. So they're going up by 12 and a half, so I need to minus by 12 and a half. And I get, oh look, starting point of 0. Which, that's quite interesting, because y equals 0 times 12.5 to the x. This is an interesting equation, because what is 0 times anything? Yeah, 0. So this is technically the equation that we got, but something's up with it. I need to go back and look at it. So if you got that, we're going to go ahead and say it's correct, and we're just going to stop from there. Okay? I'll fix it for next year. Oops. But you get the point. The biggest issue here is, could you find that, and could you use it to find that? All right? That was the biggest ordeal here. Could you find the average ratio? Or average difference in this case. All right.